Welcome back, Wolfpack. This lesson is 5.6 arc length. And our essential question is, what is the difference between arc length and area of the sector? Let's go ahead and get started. Circumference. You should be very familiar with the word circumference. This is back from elementary school days. Circumference is the distance or the length around a circle. So circumference is also known as the perimeter of the circle. But we don't call perimeter of a circle, we call it the circumference of a circle. The circumference formula is either 2 pi r or 2d because 2r is equal to d. R meaning for radius and d for diameter. So 2 pi times radius or just pi times diameter. When we are approximating, we can use 22 over 7 or 3.14 instead of pi. And our scientific calculators have a pi button. But when we are finding the exact area or circumference, then we should only use pi. And always wait until the end of the problem to round your answers. So we don't want to round and then work something out and then round again and then work something out and then round again. We do not round until the very end. We're going to do example 1 in class, but let's look down to example 2. The circumference of a tree is 20 feet. What is its diameter? Round to the nearest tenth of a foot and use 3.14 for pi. Well, the circumference formula is either 2 pi r or pi d. Now, because they give us the diameter, I want to use pi d. So they told us already that the circumference was 20. So instead of the letter C, I'm going to plug in 20. And it's equal to pi times diameter. Well, they told me I could use 3.14 for pi. So it's equal to 3.14 times the diameter. Well, in order to get the diameter by itself, I'm going to divide both sides by 3.14. On your calculator, if you divide 20 by 3.14 and round to the nearest tenth of a foot, that means 1 decimal place, you'll have that the diameter is equal to 6.4, and our units are in feet. So the diameter is 6.4 feet. Simple as that. We will do example 1 together. It's finding the circumference, but then doing something extra with that. So we'll do that one in class together. Another aspect of circles are something called radians. We've been measuring in degrees. However, there's a part of circles called radians. You don't really have to understand what it is, but just how to convert to radians or from radians. So 360 degrees is equal to 2 pi radians. So if I'm changing from degrees to radians, I'm going to multiply my problem or my number by pi over 180 degrees. If I'm changing from radians to degrees, I'm going to multiply my number by 180 degrees over radians. Okay, so just pi and 180. You just have to remember which one's the numerator, which one's the denominator. If I am trying to get rid of the degrees, I'm dividing by the degrees. If I'm trying to get to degrees, I'm multiplying by the degrees. Okay? And the degrees is the numerator. So, convert each angle measure to radian measure. Notice that it's 60 degrees. So I'm trying to get rid of the degrees. So I'm going to do 60 times pi over 180 degrees. That becomes 60 pi over 180. Well, 60, I'm going to run out of room, so I'm going to write over here on the left-hand side. 60 can go into 60 one time, and 60 can go into 180 3 times. So 1 pi over 3, or just pi over 3. The answer is pi over 3 radians. Pi over 3 radians. And we will do example B in class together. So don't worry about that one, but it's the same thing. You're going to multiply by pi over 180. So now we're going to do the opposite. We're going to convert 2 degrees. We're going to get rid of the pi, and so we're going to multiply pi 4 pi over 4 times 180 degrees over pi. So I want to get rid of the radians. I want to get rid of the pi. So that equals 180 over 4. 180 divided by 4 is 45 degrees. So pi over 4 radians is the same thing. Pi over 4 radians is equal to 45 degrees. Okay, I converted it to degrees, it's 45 degrees. We will do example 4b in class together. And this is all you really have to understand about radians and degrees is how to change them from one to the other. You don't need to worry about why, we just need to worry about how to do it. Okay, arc length is finding the a piece or a part or a segment or a section, whatever word you want to use. Arc length is finding a piece of the whole circumference. So instead of just doing 2 pi r or pi d, we're going to multiply it by a fraction to find just part of the circumference. And the fraction is determined by the measure of the arc. Is the arc 60 degrees? Is it 90 degrees? Is it 180 degrees? How much of the circle are we talking about? So for example 5, we're going to find the length of the darkened arc. Well, it's measure of the arc over 360 degrees, because the whole circle is 360 degrees, times 2 pi r, which is the whole circumference. So I'm not finding the whole circumference right here. I'm finding part of the circumference. Well, I'm going to find just this portion. This portion is 120 degrees of the whole circle, which is 360 degrees. And I'm going to multiply it by 2 pi times r, which is 9. Okay? 120 over 360. Well, I can cross that out, reduce. Now it's 12 over 36. I also know that 12 goes into 12 one time, and 12 goes into 36 3 times. This becomes 1 over 3 times, 2 times 9 is 18, 18 pi. 2 times 9, 18, 18 pi. So now I have 18 pi over 3, because 1 times 18 pi is 18 pi divided by 3. 18 divided by 3 is 6. So 6 pi inches is my answer. So that's not the whole circumference. The whole circumference was 18 pi. I needed 1/3 of the whole circumference, which was only 6 pi inches. We could also do 6 times pi on the calculator and figure out what that is. It's probably like, I don't know, 18 or 19 point something. But you only need, you can leave it just like that, and that's called leaving it in terms of pi. So we just left that in terms of pi. And if it doesn't tell you how to leave it, you could always leave it in terms of pi. That means we don't have to multiply it out. It's the same thing as 6 times the pi button. That's what that is. Okay, 6 times the pi button is 6 pi. It's leaving it in terms of pi. We will do examples 6 and 7 in class, but the main thing I want you to remember with this, arc length is we're finding the length of an arc. If we were finding the length of the whole circle, we would be doing 2 pi r or pi d. But we're finding just a piece of the circle, so we have to multiply that whole circle by a fraction. Okay? So that's exactly what we're doing here. We're taking the circumference, multiplying it by a fraction. What part of the circle are we finding? In this case, we are finding 120 degrees divided by 360 degrees, which is 1/3. We are finding 1/3 of the circumference. So arc length is finding part of the circumference. So you're dividing the circumference by something. Okay? That's what it is. If you have any questions, please make sure you are making margin notes in your margin, questions in your margin, and I'll be happy to answer them in class tomorrow. Have a great day, Wolfpack, and I will see you next class.